Good morning. Just to check, can anyone hear me? Okay, I think we're live. Good morning, good afternoon, everyone. Welcome to the Integrated Program for Better Air Quality in Asia Technology Roundtable and Fair for Combating Air Pollution and Climate Change in Asia. Welcome to the transport session. And we're going to be talking about the how we should meet the technology needs for the transportation sector in relation to how we may mitigate air pollution and improve air quality in Asian cities. My name is Alvin Mejia. I am a senior research fellow at the Wuppertal Institute here in Berlin, where I focus on international cooperation projects on sustainable urban mobility. And I'm happy to be here coordinating this session for all of you. And thank you for joining again the IBAQ. And today we will hear from key representatives from the transport sector to talk about adopting e-mobility and technology measures in the sector that will help in combating air pollution and climate change in our cities in Asia. Um, Firstly, we will hear from our three speakers about the technologies and their adoption in Southeast Asia, and hear the reactions later on from our city representatives. And then we will have time at the end of the presentations and the reactions for the Q&A. So save your questions for later. You can put them into the Q&A chat box, or later on you can also we can also put you on stage if you want to do a live question to our distinguished speakers. And without further ado, to kick off this session, let's hear first from Mr. Daisuke Takahashi of Chademo. Mr. Takahashi is one of Chademo's spokespersons and the project leader of the Chademo EPAC, or the Electric Power Assisted Cycles Charger Working Group. He has been at the forefront of product development for more than 15 years in the EPAC industry and in the large-scale energy storage industry. Takahashi-san, can you hear us?
Yes. How about you? Can you hear me?
Yes, very clearly.
Hey.
So the floor is yours.
Yes. Okay. Okay, everyone. Nice to meet you. I'm Dan Takahashi from Chademo Association. Today, I'd like to present to you about the Chademo, your solution for EVs charging infrastructure. Okay, go to next page, please. Yeah, it is needless to say, electrification is a key step to achieving the carbon neutrality. And probably, as you know, also as you know, about the quota of the CO2 emission is coming from the transport sectors, especially for the automotives. So therefore, to achieving the carbon neutrality, yes, we as a part of the automotive industry and related to the automotive industry people need to have the mission to, yes, electrify the vehicles, and as well as providing the infrastructure for charging system for electric mobilities. This is starting point of this is the mission of the Chademo. Okay, go to next page, please. Yes, today I have about the 15-minute presentation. So then today I summarizing the agenda for 3 points. First is what is Chademo, and second is one basis plus 3 principles for good charging infrastructure, and the third is summary. Okay, start up from the what is Chademo. Okay, go to next page. Yeah, Chademo is the name of the association, but in particular, what is Chademo Association means is the two meanings. First meaning is normally if you say Chademo, it means the charging standard. Especially our charging is very high speed, high power DC charging. This is the meaning number one of the Chademo. At the same time, Chademo meaning the organization of ourselves. And the organization having the many members. And inside of the organization, we are developing the standard and the product and providing the certification for the product. And also we doing the promotion of the product and the standard and our organization itself. Means that Chademo organization is some kind of the platform to make the collaboration in between the multiple companies. Yes. And finally, our vision is powering the global zero emission mobility for happiness of the future generation. Okay, thank you very much. Go to next page. Yeah, as I said, Chademo is the name of the organization. And inside of our organization, we are totally have the 500, 200, and it is more members from 47 countries. Yeah, and member also coming from the very various set of the industries, such as the automotive manufacturers, such as the electric grid power suppliers, such as the electric installation or electrical equipment companies, or such as the test and the certification institute, and others. Means, yes, our open platform is having the very variety industry and people. Okay, go to next page, please. Yes, and then I would talking about our charging infrastructure. Yes, Chademo charging point is in globally. We have the 40,900 charging point over the 95 countries. This is one of the biggest non-proprietary charging infrastructure in the world. Okay, go to next page, please. Okay, next page is talking from the EV side, electrical vehicle side. As I said, Chademo charger having the total 40,000 chargers. On the other hand, look at the electric vehicles which are equipping the Chademo. It is about 1 million EVs equipping the Chademo. And also Tesla, it equipping the proprietary charging system. However, we have the compatibility by using the connector adapter. So means that Chademo plus Tesla, we have the 2 million Chademo compatible EVs in the world. Also, if you look at the top point, the biggest EV party is the GPT, means based on the Chinese national standard. Okay, let's go to the next page. Okay, I would talk more detail about the, what is the international charging standard. As of today, basically we have the very four popular charging standard and one proprietary charging standard from Tesla. These four is one is the Chademo, two is the CCS number one, mainly used in US and Korea, South Korea. And the third is the CCS2, mainly used in European countries. And the fourth is the GBT. It is mainly used China, People's Republic of the China mainland. And today, in the later part, I would like to talk about the shirohg. It is a future standard with combination between the Chademo and the GBT, means one standard coming from Japan and standard coming from China. Okay, go to next page, please. Yeah. Okay, today this event is for the Asian countries. So then today I would talk about the EV sales in Asia. As you see, the biggest EV sales in Asian countries is GB, means China-based EVs, and Chademo is second. Yeah, this is the reason behind we at Chademo are initiating the Chaoji standard development together with the member from the China mainland. Okay, go to next page. Yeah, that's all for the brief introduction about the Chademo. And then for the second part, I would like to talk about what is the principle for the Chademo charging infrastructure. Yeah, it consists from the one basis and three principles. Okay, go to next page, please. Yeah, we at Chademo having the clear concept, what should be good charging infrastructure. And we think, we believe good charging infrastructure consists from the one basis, that is the safety, and three principles, which is number one is the sustainability, number two is the localization, and number three is the innovation. So therefore, today, I like to talk about these one basis and three principles one by one. Okay, go to next page, please. Yeah, the one basis is safety. Yeah, very basic. We put the safety as the very basic of the good charging infrastructure. And safety, yeah, is the very principle. And also, safety can be from the various hazard, such as the thermal hazard, such as the electrical hazard, such as the mechanical hazard, and also from the other hazards. And this slide showing some example what kind of verification we had made for the mechanical safety test. Yeah, as you see, we are having the test protocol for the run over test, crashing test, and drop test, and impact ball test. Yeah. So yeah, somehow this kind of run over test or other test is came from the misuse of the from the end user. However, we at Chademo, this kind of test is very important for keeping the safety, because yeah, for the end user side, we could not divide it is a misuse or it is normal use. But very principally, we need to providing the safety. So therefore, as the Chademo, we having the very wide program to ensure the safety. As of the result, on the bottom line, yeah, we as Chademo has no serious incident in over 10 years. This is one basis of the Chademo concept. Okay, let's go to the next page. Yeah, next principle, principle number one is the sustainability. Yeah, sustainability somehow very much the generic word. So then today, I like to talk about the three concepts, three strategy, which consisting our sustainability. And then first concept, first strategy is the compatibility. Yeah, Chademo is makes a very important the compatibility. Especially Chademo standard maintains the backward compatibility. It is similar like the USB. And as you see the figure, now we are developing the Chademo standard 3.0 called shirohg together with the GB China members. But yeah, since we started Chademo 1.0, soon after the 2010, it is the established date of the Chademo. Up to the 2022 at the now, we keeping the compatibility for the Chademo charging system. This is a very much important principle to keep keeping the sustainability. Okay, let's go to the next page. Yes, the second point for the sustainability is the interoperability. Means that, yeah, under the Chademo standard, we have the various kind of charger from various kind of the manufacturers, as well as we have the many kind of the EVs from many kind of the manufacturers. So then we need to ensure the compatibility in between such a various chargers and the various EVs. So then we have the program to ensure and certify such interoperability in between the charger and the electric vehicles. Yeah, this is point number 2 for sustainability. Okay, let's go to next page. Yeah, important concept of the sustainability number 3 is the versatility. Yeah, basically, Chademo believe the charging infrastructure should be versatile for the many kind of EVs. And today, under the Chademo standard, we are designing the charging standard and infrastructure for various vehicles, starting from the very big EV buses, which requires more than 1 megawatt power output. And main EV is the passenger EVs, is commercial EVs, which requires 10 kilowatt to 400 kilowatt output. And then we also are providing the standard and product for e-motorcycle and light electric mobilities, which requires a 1 kilowatt to 10 kilowatt power output. And since last year, we had just started the new project for e-bikes, officially called it IBAQ, electrically power assisted cycles, as well as e-scooters like e-kickboard, which power output is required less than the 1 kilowatt. Yeah, as you see, yeah, Chademo provides a solution for very much wide and versatile EVs. This is our concept of the third concept for keeping the sustainability. Okay, let's go to the next page. Yeah, our important, sorry, one page back. Sorry, it's okay, it's okay. Yeah, our important principle number 2 is localization. Yeah, localization consists of the 2 strategies. And the first strategy is the empowerment. Yeah, empowerment inside of Chademo, we call it the global strategy. Global means the local and global. Yeah, as you see, inside of the Chademo, we are not monopolizing everything. Basically, Chademo Association supporting the global side. Such as developing the standards, such as developing the specification, and or PR, public relationship, and education. This kind of global activity we are providing the globally, mainly from the Chademo Association. On the other hand, other things like design or manufacturing or certification or sales and the installation or operation and maintenance, this kind of things, which means directly related to the business of the each local party, we pass over this kind of the action or activity to local people. And the bottom picture is showing the optimization, localizing optimization for EV charging station. Yeah, left-hand side is it is Japan. Rest area of the highway. Charger is located in the rest area of the highway, and it only has a single slot. And then we have the some example from USA. These chargers is located in the parking lot. It has a multi-slot, and also it's provided by the private company. And the third example is coming from Europe, from the Netherlands. And this service is located in the roadside, also having the multiple slot. And the last example is from the China mainland. It is a special station and having the multiple slot. And as you see, the business style and most appropriate charging infrastructure is very much different from country to country. So then we as Chademo think that localization and empower each local party is a very much important strategy. Thank you very much. I'll go to the next page, please. And the second strategy for the localization is about the certification, means the local certification. Yeah, some of you not very much familiar with certification. However, certification is very important because certification can ensure safety and interoperability, which are key for the good charging infrastructure. And then certification can support the development of the local mode, operated, managed, and reparable, but the global conformed high quality charging infrastructure. So then we as Chademo working together with the international certification body as well as the regional certification body and providing our global standard into the local certification protocols. And you can see the logo from the certification party from the yes, global market, such as from Japan, such as from the Taiwan, such as from the USA, such as from Iran, such as from the Germany. Yeah. So finally, I would say Chademo has installed a global certification network to ensure reliable, flexible, fair, convenient, and market-oriented certification procedure. Thank you very much. Okay, go to next page, please. Yeah, principle number 3. Last principle is innovation. Yeah. If you heard about the standard, it somehow means the freezing the technology, and it is somehow conventional concept of the innovation. However, we as Chademo, we are always keeping hungry for the future innovation. We are very much, innovation is very much important, we believe. And one of the examples is the shirohg. It's a project together with the GB, and it's having the various kind of innovation, such as the high power, such as the compact connector, such as the backward compatibility or for all existing standard. Also, we are aiming for the best safety level. Yeah, means that Chademo keeps its innovation. Okay, go to next page, please. Yeah, other example of the Chademo innovation is V2G, V2G or BZI, means the vehicle to grid connection or vehicle to grid integration. Yeah, probably the participant for today, such kind of vehicle to grid solution is very much important because the vehicle to grid solution can be utilized for the energy backup, renewable energy integration, or peak shifting, or micro optimization. And this kind of technology, all of these kind of technology can dedicate to decreasing the emission of the CO2. So, and at the now, Chademo is only the enabler to vehicle-to-grid solution. This is the second example for our innovation. Yes, please go to next page, please. Yeah. I would like to show you one typical example of the vehicle-to-grid benefit. Yeah, it is Amsterdam Stadium. Yeah.
Takahashi-san?
Yes, please.
Sorry to interrupt, but if you don't mind wrapping up because of the time, thank you.
Okay. Yeah. Yes, please go to wrapping up. Yes. Okay, go to next page. Yeah, go to next page, please. Yeah, sorry for exceeding the time. Yeah, for summary, yeah, we at Chademo aiming for the transport sector to the carbon neutral and dedicate to the carbon neutral society. Thank you very much for your attention. That's all for my presentation. Thank you very much.
Thank you very much, Takahashi-san. I'm sincerely sorry for cutting you off, but we wanted to also keep the session in time. But essentially, we thank you very much for highlighting also the importance of the charging infrastructure and the main principles for ensuring such towards e-mobility transition. You talked about safety, sustainability, localization, and innovation, as well as the interactions between the global and local elements that you referred to as the local strategy.
Yep.
And we've seen in your presentation the importance of having compatibility, interoperability, versatility, and it's also very interesting to see the work that Chademo is doing also in terms of the light electric vehicles, which are are dominating, for example, in particularly in Southeast Asian cities.
Yes.
As well as the
Yep.
the public transport vehicles, which we also deem are critical in terms of wider transformation of ASEAN cities towards sustainability. So again, thank you, Takahashi-san. We'll hear from you again later during the reactions and Q&A. Okay. So thank you very much.
Thank you very much.
Thank you. Our next speaker is Mr. Takumi Shiba from Horiba. Takumi Shiba is in charge of developing analytical instruments at Horiba Limited. Most of his developing analytical instruments analyze the exhaust gas of vehicles and are used all over the world. His major is in analytical chemistry, and he has a master's degree on environmental studies at the Osaka Prefecture University. So let's give a virtual round of claps for Shiba-san. Shiba-san, the floor is yours.
Yes. I'm okay. Hello everyone. I'm Takumi Shiba. I'm in charge of developing analysis equipment at Horiba Limited in Japan. My developing product is used for exhaust gas analysis of vehicle and contribute to vehicle inspection system. So today I'll introduce about Japanese vehicle inspection system and our company's products used for it. Please move to the next page. Thank you. The number of automobiles owned in the world continue to increase. However, global problems such as global warming and fossil fuel depletion are occurring as issues in automobile society. And one of the issues in the automobile is this motorized society is air pollution. One of the causes is the exhaust gas emitted from the car. Therefore, each country has regulations on exhaust gas from cars. Please move to the next slide. This slide shows the main components in the exhaust gas emitted from the car engine. The main components are CO2, H2O, and NO as combustion co-product, and CO and particulate matter as complete combustion and incomplete combustion products. In addition, unburned fuel and impurities are also contained in the exhaust gas. And if the car is in poor maintenance, there will be a lot of incomplete combustion, which will promote air pollution. Therefore, vehicle inspection systems have been established in each country to prevent poorly maintenance vehicles from running. Please move to the next slide. In this slide, I'll explain the Japanese vehicle inspection system. In Japan, the vehicle inspection system has been applied since 1951, and it is forbidden by law to drive a car that has not passed the vehicle inspection. Vehicles that have passed the vehicle inspection will be put a certification sticker. This sticker indicates the expiration date of the vehicle inspection. It's 2 years for private vehicles and 1 year for commercial vehicles. So in other words, private vehicles need to be inspected once every 2 years, and commercial vehicles need to be inspected once a year. We can take the vehicle inspection by bringing the vehicle to the vehicle inspection site or outsourcing the vehicles to a designated factory or a certified factory. In Japan, insurance fee, taxes, vehicle inspection fees, and maintenance fee will be charged at the timing of vehicle inspection. The insurance fee is about $200. The maintenance fee is about $200, and the vehicle inspection fee is about $15. And the maintenance fee it depends on the condition of the vehicles. The inspection items in the vehicle inspection include not only exhaust gas, but also brake performance, electrical systems, and handle performance, and so on. These items were selected to ensure overall safety. This slide is, please move to the next slide. Thank you. This slide is an example of Japanese vehicle inspection site. At the vehicle inspection site, the inspection proceeds mainly in 5 steps, A to E on this slide. The first step is to confirm the identification of the car, such as the body number, and check the appearance of the car. The second step is to inspect side strips, speedometers, headlights, and brakes. The third step is exhaust gas inspection. Here, the CO and HC concentrations are measured. In the case of diesel vehicles, particulate matter measurements using opacity meter are also performed here. As the fourth step, the car is placed on the pit and the inspector checked the lower part of the car, such as checking the control device and the car body. The fifth step is to review the submitted documents and pass or fail the inspected vehicle. In today's presentation, I'd like to introduce the shirohg tester and opacity meter used in the third step. Okay, please move to the next slide. First, I'd like to explain about shirohg tester. This is the shirohg tester, Mexa 584L sold by Polybar. Mexa 584L is equipped with an LDIR filter and detector and measure CO and HC concentrations. Description of this LDIR detector is given on the next slide. Mixer 58. Sorry, go back one slide. Yes. And Mixer 584L measures CO2, excess air ratio, and air fuel ratio as other measurement items. This photo is taken when measuring exhaust gas with shirohg tester, right side. And the exhaust gas is measured by inserting sample probe into the muffler of the car. At the time of measurement, the vehicle is idling state. This figure shows the gas flow inside the Mexa 584L device. Mexa 584L is equipped with a pump which sucks exhaust gas. Exhaust gas is sucked from the tips of the probe, passes through the filter attached to the probe, and enters the device. Inside the device, the drain separator first separates the gas and water. The gas component passes through the dust filter and pump, and the CO and HG concentrations are measured on the NDIR bench, and the gas component is discharged from the exhaust port. In addition, the Mexa 584L can optionally connect an O2 sensor and NO sensor and engine speedometer and oil thermometer. Okay, please move to the next slide. Thank you. Here is a diagram showing the configuration of the NDIR detector. NDIR is an abbreviation for non-dispersive infrared. The detector mainly consists of light source, a cell, an optical filter, and a sensor. First, infrared rays are emitted from the light source. Exhaust gas containing CO and HG passes through the cell, and infrared rays passes through it. At this time, infrared rays are absorbed by CO and HG, and the amount of light changes. It is optical filter that transmit only the unique absorption wavelengths of CO and HG. With this optical filter, the measurement principle is that the absorption wavelengths of each gas is detected by the sensor and converted into the gas concentration. Next, sorry, please, next slide. Thank you. Next, I'd like to introduce the error factor of NDIR. There are various factors that cause NDIR error, but here we will introduce three. The first is dirt, such as soot. If you don't replace the pre-filter on the probe or the dust filter on the device, impurities such as soot are more likely to enter the detector. If the inside of the detector becomes dirty, the amount of infrared light will decrease. If the measurement is performed in such state, the measured value may become unstable, resulting in an error in the measured value. The second is the pressure inside the detector. If the exhaust tube of the device burns at an acute angle, gas will not flow and pressure will be applied inside the device. Higher pressures in the detector can cause measurement to change, resulting in error. The third is environmental temperature. The Mexa 584L is equipped with a temperature sensor and perform temperature compensation. However, sudden changes in temperature during the measurement can affect the reading. there are several other error factors. So the measuring equipment also requires maintenance. This is another model. Please move to the next slide. Sorry. Thank you. This is another model of shirohg tester, a Mexa 441ME that Oliver has lined up. It's easy, but I'd like to introduce Mexa 441ME. In this Mexa 441ME, the drain separator with the red circle and the pump are strengthened to improve the durability of the device. This makes it possible to stable measurement. Please move to the next slide. Next, I will explain about the opacity meter. This is the Mexa 600S opacity meter sold by Oliver. Opacity meters are used to measure particulate matter emissions from diesel vehicles. In particular, the opacity meter can measure not only black smoke as shown in the photo, but also white smoke. The usage is same as the shirohg tester, and it can be measured by inserting the probe into the muffler of the car. Please, next slide. Here is a diagram showing the configuration of the detector of the opacity meter. The measurement uses light transmission type measurement method. The main components are light source, lens, mirror, and sensor. Exhaust gas enter detector from this sample gas inlet and fill the cell. The light emitted by the light source passes through this cell, and the PM contained in the exhaust gas absorbed and scatter the light, and the light is reduced. By detecting this reduction factor with the sensor, it is principle to measure particulate matter. There are various error factors for this opacity meter, but here we would like to introduce that such as soot. As shown in the figure of this detector, if impurities such as soot attached to the mirror or lens, the amount of light will decrease. This may cause the measured value to become unstable, which is one of the cause of error. Please next slide. This is the end of my presentation. Please consider our product when introducing the vehicle inspection systems. Thank you very much.
Thank you very much, Shiba-san. Your presentation highlights the importance of emissions testing and the role that the equipment are playing in terms of ensuring that our vehicles on the road are at par with the in-use vehicle emission standards. And I'm quite sure that the audience is also inspired by the journey that Japan has taken in terms of its vehicle inspection system and the stringent procedures and tests that are being implemented. And thank you for sharing the details of the impressive equipment, the COHC tester and the opacity meter of equipment from Horiba. I'm quite sure that these are very much of interest because Asian cities, as you also know, ASEAN cities are also struggling in terms of air pollution from in-use road vehicles. So thank you very much for your presentation. And I would like to call on our last but not least speaker. Let's shift once again to the topic of e-mobility. With our last speaker, Mr. Jacquesbordemans, the Managing Director in Asia for the Chair in EV Asia. He has been responsible for the promotion of the rollout of the Combined Charging System, or CCS, in Asia, Australia, and New Zealand. And he has been working in consulting and business development, advising Western technology companies in Asia markets entry strategy, and implementing sales and marketing strategies for companies in Asia. He has an MBA from Rutgers University in the US and a master's degree in engineering with a specialization in nuclear physics and electronics from the University of Brussels in Belgium. So, Jacques, the floor is yours.
Thank you, Alvin. I will be giving a presentation about the roadmap on how to reduce CO2 as effectively as possible. I'm going to switch off my camera so that I can focus on my screen over here, if you don't mind.
Go ahead.
So we'll be combating air pollution together with charring. And how can we do that? This is by empowering to the next level of e-mobility. First of all, we can see that the CO2 levels are just increasing and increasing and increasing. And we're really now coming to the point where we have to decide, do we go to the left or to the right side of the screen? Will we go for global warming, or are we going to adapt green energy? And how can we do that as fast as possible? So Charin provides solutions for e-mobility. So Charin has developed a charging standard and a communication protocol called ISO 15118. And this is being applied on land, in the air, and on water. So when we are talking about ISO 15118-20, that's the communication protocol, and the plugs look like this. So this CCS plug can charge from 50 kilowatt all the way to 600 kilowatt. And then we have developed the megawatt charging system, which has been launched this year. And this is the first megawatt charging station, which can charge up to 5 megawatt. You can see it's a very small plug, the megawatt charging system. And in the background, it's ISO 15118. And this is really key to make sure that e-mobility can take off. And who is developing these standards are the grid operators, IT companies, EVSE manufacturers, charging point operators, very important because they are the ones who are generating money. And then, of course, the automotive industry, the aeronautics industry, and the marine industry. And then we have over 44 charging standardization organizations and testing facilities that are involved in the development, and then also, of course, the hardware. So what do you need for the next level of e-mobility to make sure that you can really get rid of all these CO2 polluters and get your CO2 levels down? Are these 6 points. First of all, single charging standard. And that is really, really critical. I'll give you an example. This is a charger that I took a picture that I took in 2016 in Korea. So this was a multiple charging standard. The problem is that infrastructure buildup will be slow because the investment cost is much higher. You also have a higher maintenance cost because you need to understand all these different charging standards. And because of that, you don't see many chargers and EV sales is slow. Now, in Korea in 2016 adopted the ISO 15118 standard, and you can see immediately how the CCS charger buildup has been growing. So here I'm only talking about 150 kilowatt or more. So, and this is a number that I got in May last year. So there must be now more than 10,000 high-powered CCS chargers in Korea. But what's more, you can see that the amount of cars that are sold in Korea, because everybody's seeing those chargers, is growing exponentially. And now in Korea alone, there are over 250,000 enabled CCS cars. Similar thing you can see in Europe, where there are now roughly about 2.8 million CCS-enabled EV cars. And the sales in 2021 alone was close to 1.2 million. So you can see once you decide on a single standard, there is immediately a growth in investment. Fast charging is obvious. The longer you have to wait is not really beneficial for an EV owner. So if you have a 50 kilowatt charger, to fill up your battery to drive 400 kilometers will take you roughly 80 minutes. As batteries develop and get better, you can go to 350 kilowatt, 450 kilowatt, and even megawatt charging. And you can see that the time of charging gets less and less. seamless roaming, this is really an important part of e-mobility, is think you have 3 charging operators in the Philippines. You would need to have 3 contracts with each of these operators. Now with ISO 15118-20, you can do roaming. Roaming like with your mobile phone, when you go from one country to the other, your mobile phone will automatically swap to the other operator without your interaction. So this is also possible with the ISO 15118 protocol. And we can go one step further, is think about countries traveling from Singapore to Thailand. If there would be different standards in every place, this will not be beneficial for e-mobility. So it's important that here again, you go for a single standard, you have a single communication protocol, and then automatically you can start roaming between all these different charging operators in one go from Singapore all the way to Thailand. Now, another very important part is secured payments. And this is important for your infrastructure. You do not want that your infrastructure is being hacked into or is being controlled by malicious persons. So there must be encrypted communication protocol because you want to pay for your charge. And at the same time, when you do V2G services, so you give energy back to the grid, you also want to be paid. And this also needs encrypted communication. Think about a car coming from a production line. Originally, these cars would never connect with any outside source. However, an EV is completely different. It connects with third-party equipment that can be anywhere in the world, and there is important information going back and forward. And if this is not encrypted, you will definitely have hackers who will come in, inject malicious code, etc., etc. A very good example is actually Ukraine hackers blocked the whole EV network in Russia for a couple of days. So encrypted communication protocols is a very important part of e-mobility, and I think this is the most critical one. Then you want also to have long-term investment protection. You can see that more and more cars are coming up with the CCS plug and the CCS ISO 15118 standard. And this will mean that this type of chargers, multiple standard chargers, will become a thing of the past. Just to give you an idea, here is, I tracked the data from this company. This is a company in Holland, charging point operator. So I tracked the data from 2017 till the end of 2021. And you can see that now more and more cars are using CCS to charge, and less cars using other DC charging protocols. What does that mean is that the old installation will become outdated. Therefore, to avoid stranded investments, you will go now for chargers that have both sides CCS. And this is, for example, in the United States, these are Electrify America chargers that can both charge a car up to 350 kilowatt. Then it needs to be future ready. What we develop today needs to be able to operate in 10 years, 20 years, 30 years. We do not want to have stranded products. What we want is the assets can be continuously used. And here it's again important that governments choose a standard which is compatible and is future ready. What do we mean by that? Is it needs to be able to do automated charging. It needs to be doing automated conductive charging. It needs to do plug and charge. Plug and charge is a service where you plug in, the chargers recognizes your contract, start charging, you unplug, and bill is paid. No swiping of credit cards, no QR code that needs to be scanned. You just plug in, charge, and unplug. And also has these roaming services. Automated conductive charging might sound far-fetched. However, in logistics centers, in harbors, you will see more and more autonomous driving. And so you need to have autonomous charging. Same with pantograph charging for buses. This is also a type of automated charging. And this will become more and more obvious in everywhere in the world. And I'm not talking here about advanced countries. Harbors already in Asia are using autonomous driving. More importantly, especially for CO2 reductions, is that the car now also can listen to the outside world. And here I want to give you the example of KEPCO, and this is something that is happening in Korea, where KEPCO is using the card as part of smart grid. And what does that mean is KEPCO, so the Korean grid operator, is generating renewables about 15.8% in 2020, and they want to move to over 40%. But they want to do that, so they want to generate wind power and solar power without installing fixed batteries. So how are they doing that? They're using the ISO 15118-20 communication protocol, which includes the V2G package. And with the cars that are on the in the field, they will be able to take in the electricity from wind and solar power and give it back to the grid. At this moment, it's in a test phase with 100 units, and by the end of 2022, it will be expanded not worldwide, all over Korea. And by then, we can expect that 200,000-300,000 cars will be starting to use the V2G service. But it will go beyond just V2G. It can also provide V2H services. If your building, your house would have a solar panel, it could put the energy in the car and give it back to the house when needed. It can do V2 loads, whatever you want to connect to your car. It can also V2 business and microgrids. Smart charging is also important if you have hundreds of cars who are charging at the same time, or even millions of cars at the same time. You as a grid operator want to be able to control remotely on an individual basis every car that is charging, so that you can reduce charging for certain cars, increase charging, or maybe stop charging. And you can do that by checking individually each car. When do you need that car? Do you need it in 2 hours? Do you need it in 24 hours, in 1 day? So depending on this data, charging for that specific car, that specific bus, truck will slow down or increase. So the whole package is basically offered by the CCS plug and the MCS plug up to 5 megawatt. And in the background, you always have this ISO 15118 protocol. And this protocol can continue developing over the years. There is no need for backward compatibility because this communication standard will remain with the same type of plugs through the lifetime. And once governments take decisive action, you will immediately attract companies who build charging infrastructure. You will have EV and charging equipment manufacturers coming in. You will see IT companies coming in. You will also see the growth of renewable energy. And a good example where this is actually happening is in, for example, in Indonesia, where Hyundai has built a huge factory only producing EVs, and they will be producing probably around, I think, if I'm not wrong, about 500,000 EVs per year close to Jakarta. And all these cars are using also CCS. I want to touch a last point, is the Philippines are consuming per day about, let's say, before COVID came, about 474,000 barrels a day. if you think about the money that is wasted, that is, if you think about $110 a barrel, that would mean on a year, on a daily basis, 52 million US dollar is blown in the air, or on a yearly basis, 19 billion. If you now would do a theoretical exercise and say, now we will put on every house solar panels, and the solar panels will be the main provider of electricity, and you combine that with V2G, that cost in 1 year would be 18.5 million. So you replace 19 million per year by a one-time investment of 18.5 million. And what can you do with this other 19 billion? Invest in education, invest in hospitals, and whatever other infrastructure that is needed in a country. So what way do you want to go? Global warming or green energy? So who is actually should have the biggest say in the charging standard? This is really the governments and the grid operators. They have the biggest say, because the grid operators, if they cannot control all these cars remotely and individually, it will be a total mess. If governments don't take decision, the market will not take a decision, and you just basically keeping on investing in petrol and buying internal combustion engines. The next step are the charging point operators, the e-mobility service providers. Then, of course, the hardware companies, the test companies, the certification companies, and lastly, the EV producers. This is really important to understand. It is not the EV manufacturer that will dictate what charging standard is being used. The EV manufacturer wants to sell cars. And if they want to sell in Japan, they will go with the GBT standard. If they want to sell in Japan, they will go with the Chademo standard. If they want to sell in the rest of the world, it will most probably be CCS with the ISO 15118. But so one car manufacturer at this moment is building cars. Yeah, I'm almost finished. Building cars with different charging standards. This should not be the case. So basically, the scope of application is on land, in the air, on water, and basically the focus is on reduction on CO2 levels in those three areas. Thank you. That was me.
Yeah, thank you very much, Jacques, for a very excellent presentation and for highlighting these elements that are crucial for accelerating e-mobility adoption and taking it to the next level, as you've said. And by addressing issues related to EV charging, we not only in terms of standards per se, but you also mentioned in relation to the systems that enable seamless charging, secured payments, and really looking into the future and planning for the future. So thank you very much again, Jacques, for your presentation. And again, we'll go now to the interactive discussions. And first of all, I would like to see whether Sir Noel Hetchanova is here with us from Iloilo City to provide some reactions to the presentations that were provided earlier. Sir Noel, are you there?
Okay, I'm here, Alvin.
Hi, sir.
Yes, glad to see you again.
Glad to see you. Yeah, go ahead.
Yeah. Okay. This is the question and answer portion, right?
Yes, sir. Or if you have specific reactions to the presentations that were given to us earlier, and please go ahead if you also have like clarificatory questions with our speakers.
Yeah. All right. So I belong to a local government unit where I am now an assistant to the mayor for environmental affairs. No, I used to be the department head of the environment department. No? Just retired. No. Okay. So anyway, we have been promoting in the past e-vehicles, and one of the major issues is charging time. And I'm very glad to hear about the recent progress in charging time. And likewise, I'm also very glad to hear about the localization initiatives of that Mr. Takumi is doing with his company as well as Mr. Borman. No? So this is perhaps the first time that we heard about smart charging, etc. No, and also I think standardization is another issue here that we are experiencing. So anyway, my question is like this: we are just a small city. We are categorized as a medium, highly urbanized, medium-sized city, and a population of half a million or more, no, during daytime. So my question is, to promote this, firstly, is we need a yes, very important financier. Okay, I'd like to know if both Mr. The companies of Mr. Borman and Takushi have explored possible financiers like banks who could uh, encourage investors, because another important component that would come in the picture are investors, of course, who would invest on the project.
Mm.
And then thirdly, very important, we need to pilot this. So if though they have plans for piloting, no? Perhaps not really a big plan, a small plan for piloting, because piloting is a very important tool for promoting this. So, like I said, this is a small city. You need to pilot this, but we have already a lot of interested people looking at e-bike, e-motorcycles. See, but not much on cars. No, so that would be my question, Alvin.
Thank you, Sir Noel. So we can probably open it up to Takahashi-san's, Shiba-san, and Jax for any specific insights on perhaps you've had some experiences in terms of working with the financiers, particularly in terms of bringing technologies and cooperation more for also the let's say the smaller cities. So yeah, please go ahead if we have some answers from the speakers. Who'd like to go first?
Well, I'll go.
Yeah, please.
Can I call you Noel?
Sure,
Yeah, okay, Noel.
sure.
All right. If you
Yeah.
want to attract investors, the investors want to have a return on their investment. And if you want to have that, if these people want to have that return on investment, you can't have a cacophony of different charging standards. It's really important that in your city and beyond, the same standards are being applied. That's a one important point. When you mention a pilot project, do you mean like a test bed?
Yeah, that is
Okay,
very important, right?
that's right. Yeah.
Oh,
So you will have to issue tenders. I suppose this is for buses, or is that for taxis, or
we have not reached that point yet, but
okay.
motorcycles, no? E-bikes
Hmm.
would be a good starting point.
Okay. Well, when we are talking about a tender, always make sure that you separate the provider of the vehicle and the provider of the chargers. Why is that important? Is that you want to make sure that the charger is a universal charging standard. You don't want that the provider of the vehicle installs something that can only charge through his charger, so that competitors are kept outside. So always separate the two, because I see that EV buses sometimes are sold together with a charger.
Mm.
You should separate these two, because that allows you later on to buy e-buses from another brand, maybe from a local brand, local made or whatever. And this is really a critical point. Although maybe the price offered by the bus supplier together with the charger might be cheaper, in the long run, it's a risk. And if you want to develop e-mobility, you want to lower the risk as much as possible.
All right.
I can get in touch with you later for examples in
Yeah.
the world. Yeah.
Yes. That would be good.
Yeah.
Thank you, Jacques,
Yeah.
Sir Noel. I think it was a very important point that you've mentioned in terms of highlighting, let's say, again, looking towards into the future and as much as possible, avoiding some of the wider negative impacts of, let's say, technology lock-in. And
Yeah,
looking
exactly. That's the right word. Technology lock-in. Yeah.
Thank you. I think we also have a few more minutes. I think another session will be starting soon, but we would. There are also some questions here in the Q&A and the chat boxes. Maybe later on, if we cannot accommodate all of them, we also encourage the speakers to also directly comment, or maybe for everyone to, if you are interested in having more discussions, please also use I think the networking function of the platform, so to get in touch. But maybe we can take one question maybe for Takahashi-san. There was a
Yes.
question here that was upvoted from Mr. Nanda Kumar Janad Hanan. Hopefully I pronounced that correctly. Localization is stressed as extremely important. Apart from charging infrastructure, what other aspects of Chademo collaborating with local partners? What is the level of involvement of local stakeholders in technology development?
Okay, thank you very much. Yes, we at Chademo, the main focus is charging station. However, if you look at the charging station is one component of the EV charging infrastructure. For example, grid supplier need to providing the grid power. Also, EV manufacturer need to providing the EVs. Also, some operator, especially for the sharing EV scheme, you definitely need such kind of service operator for the chargers. So therefore, yeah, basically Chademo, we are aiming to the hearing all of these stakeholders. Means that Chademo standard is not by initiated only the charger manufacturer, not initiated by the EV manufacturer, or not initiated by the grid supplier. So, and also, especially for the EVs or grid supply, power supply, it's very much localized standard. So therefore, for example, like developed countries, the grid power supply is very much stable. But on the other hand, in the developing countries, power supply is not very much stable. In such case, we need to apply the local standard, and also we need to work together with the local companies and the local stakeholders. This is reason behind I said localization is a key principle for Chademo.
Thank you, Takahashi-san. I think again we reiterate the importance of providing clear directions to the market in terms of standards, and you've also highlighted the importance of having these conversations with the local stakeholders in terms of the process of adopting those. Maybe I also have a question for Shiba-san, if you're on the line. I'm actually curious if Horiba is also into providing, let's say, if you have equipment for mobile applications. So, for example, if you're doing more on, let's say, outside the lab, types of testing, like on the road, random vehicle testing types of equipment, if there are specific equipment that are being provided by Horiba in that sense. Shiba-san, can you hear me?
そこに多分持っていけるような。
いいですか。
うん
どうぞ。ああ。Let me see.
オンボードやったら OBS があるし、
はい
外で使うんやったらこう配信が得るあるし。
Horiba provides not only analyzer for vehicle inspection, using outside.
Yep.
Makes a 584L. Today I introduced. That one is good for using outside, and analyzing on board. It means onboard system is onboard available. We provide the system.
Okay. So thank you very much, Shiba-san. I think for all the participants, if you would like to get in touch with our speakers, you can look into the functions of the platform, and we encourage everyone to keep in touch with the speakers, particularly if you are interested in their services and their products. So with that, I would like to thank again Takashi-san, Shiba-san, and Jax for joining us and sharing your experiences, your technologies to us and the participants. And thank you very much, everyone, for joining this session. I think we were supposed to have a 10-minute break, but we only had 3. I think there's another session on co-innovation and financing for technology cooperation in Southeast Asia, which would be starting in around 3 to 5 minutes. So with that, I would like to thank everyone, and I wish you a productive whole afternoon. So thank you very much, and have a nice day.
Thanks, Alvin.
Thank you very much.
Bye.
Thank you very
Thank
much.
you.